In this video, we're going to look at the shape of distributions for quantitative data. So the shape of a distribution can take on different forms. The shapes have names, and later we're going to talk about them and how they're used to determine statistical methods. The first is a bell-shaped or normal distribution. This is a symmetric curve with one peak. An example of data that would have a normal distribution would be the heights of American men. Now we need to be specific here, because if we were just to think about all men in the world, we may not see that symmetric curve as well. The next distribution is a uniform distribution. It is flat and rectangular. An example for data that has a uniform distribution, and it would be probabilities of die outcomes. We're going to learn more about both the bell-shaped / normal distribution and uniform distributions later in Unit 3. We also have skewed distributions. So skewed distributions are not symmetric. They're slightly shifted left or right. So we have skewed to the left and skewed to the right. Now the direction that we have our skew is the side that has the tail. So in this first graph, we can see that we have our tail over here to the left. And the second graph, we can see that tail over to the right. So that's a good way to remember the direction of your skew. If a distribution is skewed to the left, that means that the values trail off to the left, and the left tail is longer than the right tail. Another way to think about it is that skewed to the left has more data values on the higher end. So some examples of distributions or of data sets that might have a skewed left distribution: golf scores. Since there are more people scoring higher in golf, because a lower score is typically reserved for elite golfers, or scores on an easy exam. If the exam is easy, you would expect more people to score higher grades. If our distribution is skewed to the right, an example might be bowling scores. Because more people are scoring lower in bowling, where the higher scores are reserved again for those elite bowlers, or scores on a difficult exam. If an exam is more challenging, we would not expect as many people to do as well. So let's look at some different graphs and try to identify their distribution. The first is a rectangle, so this is our uniform distribution. Our next graph has that tail towards the left, so this is going to be skewed left. The next graph has that tail on the right, so skewed right. This next is that bell shape, so we're actually going to call this normal. And then this last one we didn't talk about, but this is an example of a bimodal distribution, where we've got two different values that we would see a very high frequency for. An example of data that might have a bimodal distribution is all of the heights of Americans. So both males and females would see their highest or their average at the peak of one of those. In this next set of examples, we're going to sketch examples of the type of graph indicated with its shape. So we want to draw a dot plot that is skewed to the right. So again, thinking about skewed to the right, we want a tail to the right side. So we want more values towards the left and fewer values to the right. So this could be an example of a dot plot that is skewed to the right. A histogram that is normal. So a histogram is similar to a bar graph, but our bars are going to touch. And normal, we want this to be as symmetric as possible with one peak in the center. A stem and leaf plot that is skewed left. So I'm going to give myself 4 stems, just 1, 2, 3, 4. And a skewed left, we want fewer values on the low end and more values on the high end. So if we think about our leaves, 1 is going to have data values that are like 10 to 19. 2 is going to be data values 20 to 29, so on and so forth. So this 4 is actually the higher end. So we want more data values up here with the 4 than we want with the 1. So here's a simple example of a stem and leaf plot that would have a skewed left distribution.